So just a little vocab. An expression is like a mathematical statement, but it's not going to have an equal sign in it. So 2x plus 16 is an expression. An equation is always going to have an equal sign, and it's showing that two things are equal. So like 2x plus 16 is the same as 4. That's our equation. In our expression, 2x plus 16, depending on what x is, this could have so many different answers. Like x could be 0, and then this whole thing is 16. Or x could be 8, and then 2 times 8, the whole thing could be 32. So this is one, and an expression there have infinitely many possible solutions depending on what you plug in for your variable. In an equation, there's usually only one, sometimes two, depending on the equation, sometimes three when you get into advanced algebra. But for our purposes, usually there's going to be one or two answers to an equation that will make this one true. So there's only one answer for x that is going to make this thing equal to 4. So an equation is usually going to have just one answer. When we look at expressions, we are going to have to evaluate expressions. And all that means is we're going to put in a value for x and see what we get out for the whole expression to be equal to. So if we start with x is equal to 2, we're just going to put 2 in instead of x. So we had that 2 times x plus 16, and now it's 2 times 2 plus 16. So we're going to do our multiplying first, and then we're going to add and see that it's equal to 20. But we could also evaluate that same expression when x is -3. So now I'm going to go 2 times -3 is -6. -6 plus 16 is going to go to just 10. So I had two different answers for my expression depending on what value for x I plug in. We also will be asked to simplify an expression. You'll get these big complicated ones and you want to simplify it down as much as you can. And when we're doing that, we are going to combine like terms. That's often my first step in simplifying expressions. The phrase like terms just means they're like a category or a unit. You want to think about what goes together. So variable terms, ones that have a variable like x, y, a, b, those guys are totally separate from a constant, which is just a number, like 5. So we want to make sure we put all of our variable terms together and our constant terms together. And then even inside our variable terms, we don't want to add an x and a y together because 2x plus 3y can't be 5 somethings. They're x's and they're y's. And an x might be a box of things, and a y might be a train car full of things. So we can't say, 2 bags plus 3 train cars makes 5 train cars, right? So we want to make sure we keep those separate. So looking at combining like terms, I have 3 x's here and I have minus 2 x's here. Make sure that minus 2x sticks with the term because minus 2x is the same as negative 2x. So we're going to take those guys together, 3x and minus 2x. And then I'm going to look at my other things, what's left over. And left over, I have plus 5 and plus 7. I'll just put those guys over here on their own little side. 3x minus 2x leaves me 1x, and 5 plus 7 makes me 12. And 1x I could just write as x. So really this equation in the end is just x plus 12. Or 1x plus 12 if you prefer, or 12 plus x if you'd prefer. All correct, but we combine those x's together and combine those numbers together. Let's see another example. Here I've got 8x plus 3 more x's. I'm going to bring those guys together and say 8x plus 3x is 11x. And then looking at my constants, I had -2, don't lose that negative, and -1. So I'm going to bring those together. -2 minus 1 goes to -3. So I have 11x minus 3. That's how we're going to simplify expressions. Now, it can get more complicated when we have the distributive property. The distributive property is telling you that you have something that is being multiplied by a whole bunch of stuff inside the parentheses. So we have this 3 that is being secret multiplied by everything inside those parentheses. Sometimes we draw little rainbows to help us remember it's going to go to everything in there. Another thing we do sometimes is make a little rectangle to make an area model, and we're like 3 times x, 3x, 3 times -2 is -6. But when you have an expression that has a distributive property in it, you want to make sure you multiply that out before you start adding and subtracting stuff. Thinking back to PEMDAS, we would normally start with this inside the parentheses, but we can't do x minus 2. There's no way to simplify that any further. It's not like 10 minus 2, which turns into 8. X minus 2 could be so many different things depending on what x is, so we can't simplify that farther. Parentheses, done. Exponents, done. Now we're down to multiplying, right? So I go 3 times x is 3x. We already did this on the side. 3 times -2 is -6. And then I'm just going to copy down the rest of it without changing it. Plus 5 minus x. Now I can come back to combining my like terms. So I've got 3 x's minus an x. So I started with 3 of them. I took away 1. Now I just have 2 x's left. And then my constants I'm just going to bring down. And then I can combine those together. -6 plus 5 is going to land me at -1. I still have my 2x. So my final simplification is 2x minus 1.